So the first question is from Jun2005 qu2. Two parallel coplanar forces can sometimes form a couple. State three conditions that must apply to these forces to make them a couple. So the first thing is the forces have to be equal, and they should also be opposite. And the third thing, which will really help, is that they have a different line of action. In other words, they're parallel, but they're not, well, they're not necessarily parallel, but they don't act through the same point. Define the torque of a couple. And the torque of a couple is the turning effect or you could also say that it is the product of force multiplied by the distance. So it's one of the forces multiplied by the distance between the forces. It might also help if you draw a wee diagram. So if you do a wee diagram to show your couple, then you'd have F, F, and then D between them, and therefore the torque equals F times D. But they're given a mark for saying it's a turning effect of the couple. So, I mean, you could, that's as simple as you can get it there. Just to make sure you get your mark, I would maybe do something like this here. Part B. Two wheels A and B of radius 0.2 metres and 0.5 metres respectively are both fixed on the same axle 0. Oh, so there's the axle there. A force of 70 newtons is applied tangentially to the inner wheel. There's the 70 newtons there, and there's the inner wheel. A force of 40 newtons is applied at an angle of 60 degrees to a tangent of the outer wheel B. The wheels, the directions of the forces, and their points of application are shown in figure 2.1. So there's the diagram there. Calculate the magnitude of the moment about O of the force applied to the inner wheel. So moment is just force by distance. The force is 70 newtons and it's a distance of 0.2 metres, just a radius worth of the inner wheel away from the centre. So moment equals force by distance, and that's 70 multiplied by 0.2. This is part 2. Calculate the magnitude of the moment about O of the force applied to the outer wheel B. So if we have a wee look up here, I've already marked in, the distance of the outer force is 40 newtons from the centre is 0.5 metres. Because that's a perpendicular distance, you have to calculate the perpendicular component of the force, perpendicular to that distance there. And so that's going to be 40 times the cos of 60 degrees there, this line here, 40 times the cos of 60. And so that's what you're going to multiply. So I already have it written in here, I'm just writing it over in a better colour. Moment equals force by distance, and that's 40 times the cos of 60 times a half, and that comes out as 14 newton metres. As both wheels are fixed to the axle, they move together. Calculate the magnitude of the resultant moment on the axle. So we'll just write down their two forces there. We've got our 70 newtons in that direction, and then we've got our component 40 cos 60 in that direction. And this one here causes a moment, and I'll write it in green. The 70 newtons causes a moment of 14 newton metres, and that's obviously going in an anti-clockwise direction. And the 40 cos 60 is causing a moment of 14. I'll put that the wrong way round. In fact, I've got this answer wrong. This is actually 10, not 14. That answer's 10. So the 40 cos 61 gives us a moment of 10. And so you've got 14 this direction and 10 that direction, and therefore overall you've got an overall moment of 4. And the direction then is going to be in an anti-clockwise direction. So 4 newton metres anti-clockwise. This answer is 10.